All right, we're on 4.3, lesson 22, and we're moving on from division a little bit, taking a break, and it says, I can find factor pairs for numbers to 100 and use understanding of factors to define prime and composite. So we're going to be talking about these two names today, which are really important when we're trying to decide when we're multiplying and dividing. Okay, so prime is a number that can only be divided by 1 and itself. So it's a number that can only be divided by 1 and itself. So an example of this would be like the number 3. Only 1 and 3 would be factors of 3, right? There's no other numbers that go into 3. So can you brainstorm any other numbers that can only be divided by 1 in itself? Like I know 11, 7, 5. And you can keep writing some more down when you come to think of them. But it's really nice to know prime numbers because when you're dividing and you know that only 1 goes into it, you can make your division go a lot quicker. So a composite number would be the opposite, right? It has factors more than just 1 in itself. So, of course, 1 and itself can be divided into the number. Oh my gosh, you guys. I forgot. We got to fix this. I made a mistake. Composite is not composite-y. Composite with just an E at the end, not an IE. But it's factors more than just 1 in itself. So things like 2. Oh, sorry. No, not 2. Sorry, 4. 1 and 4 can go into this number, but also 2 and 2, right? 8. 8 can have 4 and 2 go into it. It can also have 1 and 8 go into it. You can think of a number like 24. 24 has a lot of factors, right? 1 and 24, 2 and 12, 3 and 8, 6 and 4, all those numbers go into 24. So composite is more than just one number. Prime is just 1 and itself that can go into it. And we'll show examples of this. Okay, so really important vocabulary. You're going to see it a lot on testing. They're going to ask, is the number prime? Is the number composite? So it's really important that we go over this. So first thing we're going to do is 1 times 8. I'm going to draw an array to match this. So 1, 2, 3, 4, 5, 6, 7, 8. So this array matches it because it's 1 on the side, 8 on the top, right? And so when we're looking at this array and we're trying to find our factors, remember factors are just any number that can multiply into your total or your product. So these guys right here would be called our factors. Okay, that's what's being multiplied into it. They go in evenly, right? 1 on the side, 8 on the outside. Those are my factors for my array. The answer is called our product. Okay, so factors and products. When I look at this number so far, it could be prime, right? Because I have 1 times 8. But a good rule of thumb, if we have a product that is even, we always know 2 can go into it. So I can also make an array with 2 times 4. Still 8 dots, just a new array. 2 on the outside, 4 on the top, array is my product. So again, factors are 2 and 4. My product is 8. Okay, so when I'm looking at this, I know I have 2 different factors, 1 and 8, 2 and 4. So this number would be composite. It's got more than just 1 in itself, right? So 8 is composite. It's a composite number. Let's look at another number. We're going to look at the number 18. So let's draw arrays for all three of these factors. So first I have 1 times 18. So I got to make this nice and long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This one I'm going to make it in groups of 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then this one, I have the factors 3 and 6. So 1, 2, 3, 4, 5, 6, 1, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I have the product 18, or the number 18, but I have 3 different factors to get to 18. So would this number be prime or composite? 18 would be composite, because more than just 1 and 18 go into the number. We can write our factors out. So a nice way to list it is numbers that go into it. 1 goes into it, 2 goes into that number, right? Does 3 go into that number? 3 goes into that number. Does 4? No. 5? No. 6? We said 6 goes in. 7? No. 8? No. 9? And then I would go all the way up to the number 18. And what happens is that's listing all our factors. So here's all our factors for the number 18. And these actually multiply by each other. 1 and 18 make 18. 2 and 9 make 18. And 3 and 6 make 18. So you can list the factors out right here. You could do the same thing over here, right? This would be 1, 2, 4, and 8. 1 and 8 go together, and 2 and 4 go together. So that's just a way of listing our factors out. All right, let's go look at some new numbers on this side. Decide what they are. So over here we have 2 times 8 equals 16. So let's, instead of drawing an array this time, we're just going to list out our factors to see how many we have. So remember, 16 is our product. So I'm going to see how many factors do I have for 16? Is it prime? Is it composite? So I know 1 can go into 16, so I'm going to list 1. And then they already show me right here that it's also going to be 2. Then I'm going to ask myself, what's the next number in the number line? 3. Does 3 go into 16? 3 does not go into 16. Does 4 go into 16? 4 does. 4 times 4 gets us 16. 5 doesn't end in 5 or 0. 6, it goes 12, 18, so no, it doesn't. 7 does not. 8 does, so I'm going to write 8. 9 doesn't. 10 doesn't. 11, 12, 13. So none of them all the way to 16. Okay, so I'm listing all my products. So right here I can see I have more than just 1 and 16. So this number cannot be prime, right? We even know it from right there. So 16 is composite. It has multiple factors in it. And then we can show our factors. It's going to be 1 and 16, 2 and 8, and it's actually 4 and 4 go together, right? Because 4 times 4 makes 16. So now let's look at a prime number. Okay, so here's the number 7, and we talked about this when we were drawing. So if I go through my numbers and try to list them out, I'll start with 1. I know 1 goes into 7. 2, 7's not even, so I know 2 doesn't go into. 3 is 6, doesn't go in evenly. 4, 8 doesn't go in evenly. 5 doesn't go in. 6 doesn't go in, so the only other number that goes in is 7. So my factors that I get is 1 and 7. So if we go here, remember any number that can be divided by 1 in itself. So right here we have a prime number. So 7 is prime. It's only 1 and 7 that can go in there evenly. All right. On problem 3, I want you to think of all the numbers, all the factors that go into there. So we're going to make a little table called factors of 35. Okay, and what I want you to do on your table, and we'll check it tomorrow, is I want you to list factors of 25. Okay? And you can keep adding boxes if you think there's more. You can delete a box if there's less. But list what are the factors. And then tell me, is it prime or is it composite? Just write it here on the bottom. All right, and I will see you tomorrow.